Hello, it is Dr. Lou. In case you have not watched the prior videos, I am the lead faculty member who has created the online laboratory classes using kits from Science Interactive. In today's video, I'm going to review how to draw Lewis structures, build models, and complete the data table in the lessons. So today we are going to look at molecular models and drawing Lewis structures. Let me give you a brief overview of how to go about this particular process. So the first thing we want to do when drawing the Lewis structures is to use the given formula, and we need to count the total number of valence electrons. Then we want to draw the correct Lewis structure using the appropriate number of valence electrons. Next, we can count the number of groups and lone pairs around the central atom. Finally, we can build a model and name the shape. So we're going to consider the covalent molecule CH3COCl. The way I have written the molecular formula is to give you an idea on how everything happens to be connected. So let's start with the first step. So the first step is going to involve counting the number of valence electrons. So we have two, let's see. Oh, I need to go down just a little bit. We have 2 carbon. And so for each of those 2 carbon, they are going to have a total of, let's see, 4 electrons. So 2 times 4 E negative gives us a total of 8 E negative. Next we have, let's see, hydrogen. We have 3H. 3 times 1 E negative is going to give us 3 E negative. Now we have an oxygen, which has a total of what? Oxygen has 6 E negative, and then we have chlorine, which has 7 E negative. So now let's add everything up. So when I add everything up, what do we get? We get 11 plus 13 gives us 24 E negative. So when we draw this particular Lewis structure, we want to use 24 and only 24 electrons. So let's move this off to the side, and we'll keep this here so that we can use it a little bit later. Okay, I'll put this up at the top. So now we want to draw the Lewis structure. So when drawing the Lewis structure for this particular experiment or lesson, some of the molecules you're going to run into have more than one central atom. So what is usually going to be the central atom, if at all possible? If at all possible, the central atom is going to be carbon. And let's see. Yep. Whoops, there's the carbon. So we have 2 carbons in the molecule, meaning what? That we have 2 central atoms. So I'm going to draw my 2 carbon. So now I have drawn my two central atoms. The carbon on the left side, according to the formula, has 1, 2, 3 hydrogens. The carbon on the right side has an oxygen and chlorine. If you remember from lecture, everything needs how many dots? Everything needs 8 E negative, except, what is the exception? The exception is what? Hydrogen. How many dots does hydrogen need? Only 1. So I am initially going to give everything 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now let's count the dots that I made. So the dots that I made, if you look at the carbon on the left, there are 8 dots. There are 8 dots around the oxygen. There are 8 dots around the chlorine. 3 times 8 gives us 24. And there is the lone pair. So 24 plus 2 is going to give us 26 E negative. So does the 26 E negative equal the 24 E negative that I used early, that we came up with earlier? No. These two are not equal. What does it mean when they are not equal? We need to get rid of a lone pair somewhere and add a double bond. Remember that oxygen wants 2 bonds and 2 lone pairs. Carbon wants 4 bonds and no lone pairs. So I can put a there, and then I will just erase. Whoops. Let's see if I can do this. Just get rid of these. There we go. Hopefully that makes sense. So now if we count, there are a total of 8 electrons on the carbon on the left, 8 electrons on the chlorine. 8 plus 8 gives you what? 16. And then there is another 8, including the 4 shared electrons for the oxygen. So now we do indeed have what? 24 E negative. So we are correct. In lecture, not in lab, you are asked about polarity. So in order to help us understand molecular polarity, I am going to change this drawing. And I'm going to remove the shared electrons and replace them with a line. So let's fix the C, and then I can put a line to represent. And I just drew 2 lines. Those 2 lines represent the double bond, and then we can put in 2 lines for the chlorine. Actually, no, 1 line for the chlorine. Okay, so now we have the correct Lewis structure. So now what do we want to do? We want to come up with the name and then build the model. So before we can come up with the name, we are going to want to count the groups, and we want to count the lone pairs around the central atom. So Because we have two central atoms, I'm going to label, let's see, left, and we're going to label right. So looking at the carbon on the left, there are 1, 2, 3 hydrogens and 1 carbon, giving 4 groups, and there are no dots, no lone pairs. Looking at the carbon with the oxygen, there are 1, 2, 3 groups, no lone pairs. So what is the name of the geometries? The name of the geometries for the one on the left, so I'll write this as geo, is going to be tetrahedral. And the one on the right is going to be trigonal planar. Hopefully that makes sense. When dealing with trigonal planar, we have to write trig and we have to write the word planar because it contains a double bond and is flat. Okay. So moving on. Let's see. I think you can see this. I put up a table heading. So this is the table heading from the data table you're going to complete online. So you'll be given the molecular formula. You will count the valent electrons like we did right here. This middle total number of atoms and lone pairs, that is the number of groups. So because there are 2 central atoms, we would write 4 and 3. Structure or geometry name would be trigonal planar for the right and tetrahedral for the left. Let us conclude by looking at how to build the models. To make it a little bit easier, I have some photographs that I took and I want to show you. We're going to look at building models. So I have a picture of some pieces from the model kits supplied in your kits. I want you to notice when we make a single bond, we use a short stick, one of them, and it goes in between 2 atoms. So at the top, we have let's see if I can do this right. We have a single bond. Next, if you want to make a double bond, notice we use 2 flexible long sticks. When you connect 2 flexible long sticks between 2 atoms, you can bend them and they will connect. Finally, if you want to make a triple bond, for a triple bond, we need 3 long flexible sticks. And all 3 long flexible sticks will connect to the same 2 atoms. You may have to work a little bit, but they will connect. So, if the Lewis structure contains a double bond, you need 2 sticks going between the same atoms. And if there is a triple bond, you want 3 sticks going between the same atoms in a manner such as this one. So let us end with a look at the actual model for the structure that we just drew. Over here is the carbon with 1, 2, 3 hydrogens connected with short, rigid sticks. The carbon has a tetrahedral geometry. Notice how it is sticking out towards you. It is connected with a straight, rigid stick to another carbon. This carbon is connected to the chlorine and oxygen with the double bond. The other flexible stick is going away and we cannot see it. What are these pink? These pink plates happen to be the lone pairs. It is completely optional if you put the pink plates on atoms that are not the central atom, but technically any empty holes in the balls that do not contain a stick should have these pink plates attached.